Currently, most of the municipal solid waste, trash, is disposed in landfills, creating a land use problem. A considerable amount, 68% of this waste, is amenable to composting. Composting decomposes this organic trash into a stable soil amendment. Recent research has also found that compost can dramatically increase the carbon sequestration ability of soil, and therefore could be a factor in finding solutions to global warming. All of the waste managers that I talked to are looking for ways to decrease the time that the composting process takes. I wanted to see if I could find a simple way to speed up the composting process. I broke up the experiment into two phases. During phase 1, microbial activity was correlated to the temperature of the compost pile, so that managers could use simple tools to measure critical parts of the composting process. I started phase 1 by building bioreactors out of styrofoam containers. I got my materials for composting from my local grocery store, Hy-Vee, from produce that they were going to throw away. I then started the 10 bioreactors and measured both the temperature and microbial activity of these 10. I then correlated them and found that it had a strong correlation between the two. In phase 2, I tried to reduce the composting time by using an indigenous inoculation of compost, aka hot compost. For the experimental piles, I replaced 30% by weight with the inoculant. I made a total of 12 experimental and 12 control piles. I found a 14% reduction in time to stabilize. I used the Mann-Whitney test to determine if the data was statistically significant. It was significant to the 0.05 confidence level. My experiment shows us that we don't have to leave trash in landfills. A good portion of it can be composted. The compost is a tool that waste managers can use to sequester more carbon and fight global warming.